I'm Telly Mahoney, and welcome back to The Good Room, where we have interdisciplinary conversations about what makes a room good. And today we're talking about the design of good biocontainment laboratories with Rohit Saxena, a science and technology market leader, and Jane Baughman, a principal and technical director. Before we get into the main portion of this conversation, I wanted to ask each of you what got you interested in designing laboratory spaces and living in the science and technology world?
For me, it just started off as me being a tinker from the time I was little and got into architecture school. And somehow the first job that I took was with a firm that did laboratory work. So I did a bit of lab design, did a couple of other projects like parking garages, clinics, and so forth. But my interest has always been in science. I'm very intrigued by how things work, and especially when it comes to physics and movement of air and how things lift and fall and so forth. And you never realize how these things all come together. And after, working a bunch of years, you look back at your career. It's not, I woke up one day and said, I want to be a science guy. But I looked back and said, hey, I think I may be a science guy because I kind of like it and I enjoy doing that. That's how I got into it. And then I would say of the 40 years, I would say the last 30 have been pure science. And it's been absolutely fascinating. Jane, how about you?
When I was a kid, I used to draw on everything, anything and everything, like recess was drawing. And then I began to notice that the reason I enjoyed it so much wasn't because of the expressiveness of drawing. It was the technical aspect of drawing. It was the challenge of being able to draw something that looked photorealistic and getting it technically right. And that's when I began to realize creative problem solving is my gig. And when I got out of architecture, I didn't immediately jump to be an architect because it seemed like there were so many other things out there that I really wanted to do. And I happened upon being a furniture designer for a company that fabricated scientific casework in fume hoods. And I got really into that to the point that I developed and pitched a scientific casework line that they accepted and started manufacturing as a special line. Anyways, I eventually decided I'm going to use this architecture degree I have. And I kind of went into architecture and did a bunch of other stuff, but I kept gravitating back to laboratory planning and working with scientists because it was kind of the first thing I did that was in that creative problem solving realm. And it still psychs me up and I can geek out on it. So it's just really rewarding. It always has been.
And I think for both of your cases that you're really enthusiastic about this topic. And I can tell that it's something that you really love to do. And so moving into the main part of our conversation, I wanted to build some context about what a biocontainment laboratory is. So can you please describe to me what is the difference between a biosafety level 1 and a biosafety level 4 laboratory?
One of the key aspects of this is to really understand what you're working with, right? So when you have at the basic level of biosafety level 1, that's just for standard microbiological practices. That's the kind of thing that we were talking earlier you can do in just about any lab. So when you go to the next level, which is the BSL2, which is most research laboratories that you have. So, you have certain things that you have to add an extra layer of protection in it. You may have some PPEs, some gloves, eye showers, and things of that nature. Now, when you get into the next level, which is biosafety level 3, there are other protocols because that now needs controlled access. You have to have decontamination of the waste that is coming in. From time to time, you have to decontaminate the entire lab. And at the highest level that you get into, of course, is the BSL-4. That's when you're actually dealing with very dangerous and exotic agents that might pose a very high risk to the people that are working. And it's important for designers to actually have a conversation with the users to truly understand their operating procedures and the protocols they're using to then be able to give an advice back on what design direction.
Also, what is the difference between a containment facility and a barrier facility?
The way I look at it in a simple way, as the word containment suggests, it's to contain. So what you're doing is you're containing all of the germs and all of the pathogens that might potentially infect people. So that's a containment. The flip of it is a barrier. in which you're not necessarily protecting the people, but you're protecting the product. So, for example, at Jackson Laboratories, they produce mice that are then sent across the country and the world to researchers who may be there may be pathogens and others, infections that they're studying in mice. But the mice itself, when they get to the researcher, have to be certified clean. So there's a concern that you produce them in the most clean environment. So you put a barrier so that any of the dander or cells or skin things or whatever from the human body doesn't get into the mice that you're producing. So in a barrier, you're pushing out, and the containment you're keeping in.
And there are primary containment pieces of equipment. Your primary containment unit normally is either a fume hood or a biosafety cabinet. Along with that, there are secondary environmental controls, which is the mechanical system that goes with that space. And that mechanical system is designed to ensure that there's zero airflow, either going out of the lab if it's containing or coming into the lab if it's a barrier. And that is one of the primary tools to ensure your lab is functioning. The tertiary part of that is the actual architecture, which are the walls and the doors and the locking system and everything that's specifically built. And usually it's built in layers to ensure that there's not going to be leakage going through those components and those parts of the laboratory. And the primary way that we verify that is through construction, just visual inspection.
How do you clean it and make sure that it stays maintained over a longer period of time?
Everything usually needs to be autoclaved out, and you can design in vaporized hydrogen peroxide systems that can fog the room. You can also bring in mobile systems. Usually it's some type of vaporized agent that comes in and will deactivate the select agents or the hazards that they're using in there. A lot of the time it's working with the researchers to understand how they want to section off the rooms. The BSL-3 itself is only required for you to contain within the primary boundaries of the BSL-3. But you may have actual separate tissue culture rooms and other types of laboratories within that bubble of the BSL-3. And each one of those spaces, the researchers may choose, they're not required to, but they may choose to actually treat those as individual decontamination areas.
One of the big things that we have to remember when we are designing these facilities is that there's a difference in the coatings, in the way you handle all the coatings and finishes in the space, because the cleaning agents that your client may use as part of their facility can actually do some really bad stuff to your finishes if you haven't planned it properly. For example, if the painting in your rooms are not properly coated or of the right thickness, when you're using this VHP, which is a machine that blows this vaporized hydrogen peroxide, if it gets behind the paint, it peels it. And if any of this peeling happens in a containment or a barrier facility, it's very difficult to go back in and fix it without decommissioning that entire space.
So as you guess, the devil is in the details, right?
Yes.
So it's where your wall touches your floor and understanding what that lapping detail is. If you have boxes that sit in walls, how do they get put into either the CMU or the JIP? That is your wall, to where you can ensure nothing gets behind the box. It stops at the face of that wall. So sealant details are critical. Understanding penetrations through walls are critical. Understanding how doors operate and making sure that the door frames are sealed up, and understanding the door undercut and how it's supposed to be working in your facility to make sure that you're going to be getting the right details done for you to be able to manage cleaning a room, making sure, as Rohit said, that the epoxy doesn't bubble off the walls, or you don't all of a sudden have strange things growing behind your boxes, stuff like that.
You know, what I will add to this, Tully, is the maintenance part of it that one has to be thinking about once the facility is operational and you're going through a protocol in which you're, derobing and going through an air shower and changing and doing all of that. And you've got a animal room with mice in it and so forth, and a bulb fuses, or you've got a clogged drain. Now, that tool that you're going to use has to go through the cleaning process. You can't just walk in with it. So oftentimes you have to be thinking about that level of detail. So for instance, at this animal facility that we did, we actually have spaces within the animal rooms that have all of the tools that one might need. Almost sort of think of it as somebody on a spaceship and they have to do a bit of maintenance. You have the tools available.
So far, I've been imagining a laboratory that's kind of empty, it's pristine, it's newly built. And now I'm thinking about putting those scientists in and how you also design for the work that they're doing. So more specifically, I'm curious about how might you design the laboratory to encourage collaboration or help the communication between researchers who are working together?
So a good part of what supports the BSL-3 is the other spaces in and around it. So there's normally a BSL-2 that goes along in tandem with your BSL-3 that you'll use as a preparatory space, depending on how you want to manage that box within that box design. Your BSL-2 may actually be your entry path into your BSL-3. And those are important spaces to look at for collaboration. In the BSL-3 itself, sometimes you can get away with having like a general equipment room, which will have imaging, microscopy types of procedures in it that can be somewhat shared. And that sisters along with individual rooms where select procedures can happen. In my experience, it's often been based on the tissue culture. So you'll have maybe a series of tissue culture rooms that are co-joined by a corridor. And then there is an open lab that supports those tissue culture rooms that's in the barrier that gives researchers who are in there, who may be working on different agents, actually, the ability to actually interact in an open space within the barrier. And then, as they go through their SOPs to get in and out of the BSL-3, there are spaces just outside of the BSL-3 that are less biosafety secure and can allow for more interaction as they move out of that. But those support spaces are really important. And those are the spaces that really benefit the researchers in being able to collaborate.
One thing to support what Jane was talking about and remind ourselves is that this whole containment/barrier are levels, not levels as in BSL 1, 2, or 3, but these are levels of pressurization, if you're using that as an example. So you will have the highest level of barrier maybe in a room where the animals are or where the research is. Then you get out into the anteroom, it's less. And then you get out of it, it's less. And then you get out into the BSL-2, it's less. And then you get out to the public corridors where they may not be. So instead of that layered approach, and what you do in terms of collaboration depends on which part of the layer you're in. So the more you go out, the more collaboration you can have, the more right? If you're in a BSL-3, oftentimes they may not have a window too, because you're trying to keep it a pressurized boundary, and the best way to do it is keep it sort of internal to the building. So that's something to keep in mind.
I think an important question that comes up, and it's kind of funny, is where is the toilet in a BSL-3?
Oh,
Because
God, yes.
when you go in, you're going into the BSL-3 for targeted research. You're there for a specific thing you want to get done. And we're all humans. We all have biological functions that need to happen. So understanding like you're in the middle of doing research and you need to get to a facility, that can be a really big thing in a BSL-3. And going through that process of, do we have a restroom in the barrier, and how does it segue into decontamination, and degowning in that process is really important. And it kind of segues into just talking about those standard human spaces.
The further out it is, the more steps it is to get to it. But the closer it is to the inner sanctum of layer, the more expensive and complicated it is. So you got to find the sort of that happy medium that somebody could get to without having to go through the entire process of degowning and cleaning and stepping out when you really need to go.
It's a little off of the human factors. Rohit, you had mentioned that some of them are windowless spaces. And I recently did an episode on control rooms, which are also don't have windows. And we talked about the lighting controls that need to go into that facility so it stimulate your circadian rhythms. Are you thinking about that as well? How do you accommodate a space without a window?
You hope researchers are not spending 12, 13, 14 hours in the BSL-3. But we do look at light because light impacts your ability to do research, especially when you're doing imaging aspects where you have to identify things by color. So getting color correct lighting or having lighting in the facility that can adjust now is common. It used to not be quite as common with LEDs. You can put in systems. But again, that is a system you have to really start thinking about early on in the planning, because there is going to be a cost to the level of control that you want to have for your lighting system.
Even though we're talking about containment and barrier facilities, a consideration is lighting that impacts animals in a mouse room. You've got mice that you may be using to breed or for research, and you have to be mindful of their circadian rhythm too. So many of these rooms have lighting controls that are simulating a day and night cycle for the animals that are within. Now, you've got human beings that are going in, and they're working at times where the mice, if that's a rodent facility, might be on a sleep cycle. So oftentimes we have those considerations in place, and those might be things like red sleeves on light fixtures on LED lighting that the mice don't perceive, or sort of automatic timers that come in and out into a facility throughout, so the animals are able to maintain that circadian rhythm.
We're gearing up towards our end of our time together, so I was thinking that we could talk some about upcoming trends and the evolution of these spaces. The hot topic that you see across the board is AI automation. Is that filtering into the laboratories at all? Where do you see that happening?
It is. I haven't yet seen it filter into the higher containment labs, but I have definitely seen it begin to filter into diagnostics and research laboratories. And I think it gives us a real great opportunity to where you can have a BSL-3 that people don't actually have to enter into. It can be a completely automated space. They've taken the idea of the automated arm, like you see in NASA doing work, and have scaled it down and put it on a rail that can now run up in front of the benches. So a researcher on another continent can set up a research flow, program it into a computer that talks to this arm in a laboratory that's completely sealed. Obviously someone needs to get the agents into it, but once the agents get into that space, the arm has the ability to manipulate the containers. It has the ability to move well plates and different types of flasks and everything down the analyzer line so that you can basically conduct a BSL-3 experiment without ever having to have a person enter into that environment and be exposed to those agents. It's going to change, I think, how we look at designing laboratories, because it's not going to be a discussion as much about space as it's going to be a discussion about flow. I dabble in other areas where we'll talk to researchers and we'll ask them like what your recipe is, in order to figure out what they need and help them understand their equipment placement, rather than coming in and saying, how much space does this equipment need? We're going to come in and say, what is the flow that has to happen so that we can set up the robotics for that. And then we can figure out what the space really is. Because once you take people out of the environment, equipment can condense, but you're adding much more space into that area because somebody now has to maintain all of that condensed equipment. They have to be able to get in there and pull things apart. And that's now what you're designing for rather than designing for people getting around that equipment.
We have seen or have been seeing for a number of years is that there's a lot more emphasis in the scientific community on instrumentation and analytics. So even though you still have a lot of basic wet bench type research, but we're seeing more and more instruments making way into laboratories. And that's sort of a natural way through which these analytics will feed into the AI system. And there are some people who have started to now treat wet labs as if they're core facilities. And by core facilities, what I mean is they don't really belong to an individual researcher, but they're shared specialized spaces because a lot of what you're doing doesn't require you to have your own dedicated space. But there's equal number of controversies around it, or people are going to push back, because at many levels, people are still doing basic research as they've done for years. But AI is definitely finding its way into our projects. And the reason from an architectural standpoint it's important is it might change the proportion of the specialized spaces to more computational spaces that you might use.
Yeah, I think that's one infrastructure we haven't really talked about is data, telecommunications. Bioinformatics is a big thing. Being able to sift through big data is huge. And being able to supply the telecommunications network for some of these pieces of analytic equipment that can process for 3 days before they shoot out information on something, especially when you're doing next generation sequencing. Those are long processes. There is a huge amount of data generated from that. So for the users in those facilities, thinking about that data infrastructure and how you're going to collect it both in the box, the BSL-3, which there might be a little data collection box next to it, basically computer next to it, that's a booster. And then the network pathway getting out of there, because you're sending enormous amounts of data out of that facility to be able to be churned through somewhere else. So the size of your network can sometimes be 2 and 3 times larger than what you would expect in a standard laboratory.
Awesome. It's always so fascinating to hear how technological advances are changing the way that we think about our spaces and how we design them. And I think that also concludes our conversation today. I want to thank you both, Rohit and Jane, for joining me. And I want to thank everybody who's listening today. Please don't forget to subscribe so you get notified for our next episode. Thank you.
Thank you. Thank you for having us. Yeah.
Absolutely.